Hello, everyone, and thanks for dialing in today. If you are looking for some randomness in your life, then you probably have come to the right place. We are all about randomness and providing it as a free service, free public service to the internet. In today's discussion is going to be more about what exactly were the motivations that we had in mind, and what sort of a gap out in the industry we were trying to fill with DRAND. So DRAND is fundamentally so DRAND is actually a randomness beacon, which can be used as can be seen as a foundational internet protocol, pretty much very similar to what the other protocols we have. So as a quick introduction, DRAND is a distributed, bias-resistant, unpredictable, and publicly verifiable source of randomness. And as of August 2021, I think a few months ago, DRAND completed over 1 million rounds of randomness and actually already has 16 independent collaborators, partners who run the network. So in today's session, I only have 20 minutes to cover, so I'll not be able to go into a lot of depth about DRAND in particular, as I would like to cover, I would say, more of the breadth as to what DRAND actually is and how it's used in Filecoin, to be very honest, which is one of the biggest users and the most largest production user of DRAND. So today we'll cover, just go through some introduction about, why do we need randomness and what are the different kinds of randomness that we can potentially use, and then go into a little bit of detail about how DRAND works, and then we'll look at how the League of Entropy and Filecoin provides this as a service to the internet and how Filecoin actually uses it. So jumping into the motivation, I mean, as you can see, I mean, if in any not only blockchain systems, but various types of systems, you always need some sort of a random value or a random number that you can use for fulfilling various functions. Now, in this example, if I don't really have a reliable source, or if the number is not truly random, all the following computations kind of are pretty much pointless and meaningless. So why do we need good randomness? Randomness has many use cases, and as we have seen in public forums, we have lotteries, jury selections, elections that happen, the selection of auditors, the selection of people at the booth. So anytime you actually want to select from a large number of fair play or even players, you need an unbiased and a fair way of selecting them. So, for example, in cryptography, a lot of the protocols, they actually do the leader election in like proof of stake blockchains such as Filecoin, or even for the Tor protocol. They actually need to select a particular player or an entity or a particular path in a fairly open manner, in a fair manner. So there are things like even in statistics, when you have a large data set and you want to select a sample from the particular set, you need to do that in an unbiased manner as well. And especially, nobody should be able to predict what you are going to select next. Otherwise, the entire basis for the computation kind of falls apart. So, but the point is, randomness is good, but why do we need good randomness? I mean, there are a lot of implications of having bad randomness. I mean, as we have seen in lotteries in the past, there are millions of dollars of funds have actually been rigged because someone was actually able to essentially hack into the system or predict the future values and then play to their advantage. So we saw the hot lotto fraud scandal, $14 odd million in prizes kind of rigged away. We also saw in the case of Linux systems, for example, where there's actually the encryption seed. If that can be predicted, then all the future signatures that are used for encryption can actually be forged as well, and of course it leads to a huge security vulnerability in the system. So what we talk about randomness all the time, but we didn't ever think about how do I actually get this randomness? Like, should I get it from one particular entity, or should I do it by myself, or should I go out and see if there are an abundance of other people who can actually help me get some good randomness? So surprisingly, we found that there was not really a very good or a reliable source of randomness, and that's exactly what we decided that, hey, we actually want to plug this gap starting with Filecoin, when Filecoin was getting launched, we said we want to make sure that we are relying on a good source of randomness, which has these particular properties, the properties of being unpredictable, of being bias resistant. That means no one particular party can actually predict what sort of or determine the types of values that can actually be generated. It should be publicly verifiable, because all blockchains, like Filecoin as a blockchain, for example, is a public system. So anybody out there should be able to publicly verify that the output was never biased in any particular way. And most importantly, with the entire emphasis of Web3 being decentralization, we didn't really want to use one single source or organization or entity as a source for the randomness. So we wanted to make sure this is actually is put together, the random values are put together and sourced from multiple places, and from parties who are fairly independent of each other. And of course, as with any internet service, we want this to be highly available. So with that quick introduction, I'll move into DRAND and explain what DRAND is and how it's been constructed. And again, with the caveat that with the lack of time, I probably need to skim over a bit of detail, but fundamentally, DRAND uses the concept of threshold cryptography, which actually allows us to combine the inputs from many cryptographic protocols to create one final value, which means that if I have a total of n participants who are contributing the randomness, I only need a threshold, which is typically, which I'll explain further, which is the minimum number of players who need to be who I need to rely upon to capture those random values and then generate a final value. And by generating a threshold signature, we can actually derive verifiable randomness in a decentralized way. We'll talk about that further. So here there are two parts, two phases for generating the randomness. One is the distributed key generation process, in which all the participants who actually want to participate in a particular round or to generate random values, they need to first agree upon a predetermined set of parameters. And the second part is where once those parameters are determined and the initial setup is complete, they actually move to generating randomness at a predefined interval, so to speak, or a frequency, where they combine their own individual partial signatures and they generate one final value. So, and this is supposed to be a lightweight and fast protocol in which we don't really want at every interval that individuals will actually have to wait for each other. So instead of that, we basically rely on achieving a minimum threshold. So if we have, and we can talk about that next. So DRAND is fundamentally, as I said, a software run by an independent set of nodes. Like there are a bunch of servers, independent servers running all over the world, which collectively produce randomness. Now, decentralized randomness, like I mentioned, is produced using threshold cryptography, in which I only need to have a threshold, typically n by the total number divided by 2 plus 1, like a majority of the number of generating nodes. We are able to bind or combine together the independent entropy sources or randomness sources into a publicly verifiable one, right? And for that purpose, we use the BLS signature, and we can talk about that a bit further. Right now, DRAND has been running for over a year, and it's a production grade service. So it's tested, it's audited, and it's globally deployed. And the best part is you can actually access DRAND's randomness using just a curl call to the public APIs that we have. So how does DRAND work? Very quickly, like I mentioned, a distributed key generation ceremony. The parties or the nodes that come together or have decided to join the network, create a network. They actually define the threshold parameter, the minimum number of nodes that need to generate randomness, and the period or the interval at which this randomness is going to be generated. And once each node in this process, they generate their own keys, sourced from their own a variety of ways of generating randomness. Somebody's using a lava lamp, somebody else can use a cha-cha protocol, and each of them can actually use their independent sources of randomness to generate their own signatures. And once that initial setup is complete, we can start generating randomness ad eternum, like on a continual basis. So at every epoch, which is basically the expiration of a particular interval, in the case of Filecoin, that is 30 seconds. Each node broadcasts their partial signature to the rest of the network, And each node in that particular network, and when I say to the rest of the network, means at least a threshold T number of nodes who need to receive that the signatures. And each node amongst those T collects these signatures and then uses the BLS, the Bonnet-Lin-Shakam BLS signature method to actually verify that all the different partial signatures are valid. And if this signature is correct, then the randomness is simply the hash of that particular BLS signature. So it's a fairly simple and a highly performant system. So I'll probably skip this in the interest of time, but DRAND is also a chain. It's not exactly I would say a blockchain system which relies on incentives. It's an incentive-free system, but it does have the same constructs of a blockchain in which the values of the previous rounds is actually used to generate the value for the next one. Now, we are actually working as a future direction is to break this chain, so to speak, so not to have this dependency on past values, because there is no real impact on security. Security is entirely reliant upon the threat model. So, and this is currently a work in progress that we are doing, in which we are unchaining the randomness, so not creating a dependency on previous round values. This will actually help us to create temporal signatures, or what we in other circles call time lock encryption, in which this can actually be held. This can actually enable us to mitigate front-running attacks and MEV and those things. So stay tuned. With this, I want to jump into the League of Entropy and discuss about why this came through. So as we all know, 35 years ago, the internet needed a way to be able to tell the time or agree upon time. So people actually built a foundational internet protocol to synchronize distributed clocks and provide a publicly available network clock, so to speak, right, with very little skew. And that's NTP, the network time protocol, right, in which there are layers and layers of distribution and of generation and distribution infrastructure that distribute this information over packet switched variable latency data networks. So it's similar to that. Today, the internet needs a way to get randomness. Just how we wanted to get time, the internet needs to get good randomness. And that's why we need a foundational internet protocol to create a verifiable, unpredictable, unbiased, decentralized source of randomness. And this should be publicly available to anybody, anywhere in the world. Well, here we go. So here is where the League of Entropy kind of helps us out. They actually came in and to save the world pretty much from the lack of good entropy, good randomness. And essentially the intent was to create something very similar to NTP, a foundational internet protocol called, so in this case, we call it DRAND, which is a randomness generation and a randomness distribution network that can be scaled across the internet. So we have 3 layers. We have DRAND nodes, we have DRAND relays, and we have DRAND clients. And we'll talk about that a bit more. But just a very quick overview of the League of Entropy. The League of Entropy is a global DRAND network composed of multiple independent, diversified, like-minded, savvy organizations who came together in June 2019, to form, the network. What I was talking about in threshold cryptography is the minimum set of independent parties that need to come and agree upon to create a network of T signatures, of threshold T signatures. So today we started with 10, but today we have 16 members, and we are in the process of onboarding more. And we have 23 DRAND nodes, the actual sources of randomness, which in this case obviously means that we only need a threshold of 12 to kind of agree upon the final signatures. So the goal of the League of the League of Entropy is to provide randomness as a service to the public, and it's free, completely free. Anybody can access it, just the way DNS, NTP, certificate authorities, and certificate transparency are all publicly available and consumable protocols. DRAND can become the foundational internet protocol for randomness. And with the evolution of Web 3.0, it actually makes sense that we come together, different people come together instead of trying to pick each other apart. I think we should come together and participate in this extensible and pluggable network called like DRAND, for example. So in this case, the most a key aspect of this, I would say, which I would highlight, is the decoupling between the distribution network. So DRAND is a production-ready network, but how do we scale it? How do we make sure that it's actually secure? How do we make sure that this has enough liveness or enough reach across the world? So decoupling the distribution network from the source of randomness generation, which are the DRAND nodes, was an architectural choice that we made, and it's worked out very well for us. We actually rely upon relays, DRAND relays, both HTTP relays and gossip sub relays, as well as CDNs to cache values for anybody who wants to access past rounds. And of course, with anything of internet grade, we want to have continuous monitoring. But the most important aspect here is that it's a decentralized network, which means that it's a highly resilient system. So out of the 23 nodes that I mentioned, we only need 12 to be available and be available to participate in the creation of a new network. And failure, so it's a lot more fault tolerant, so to speak. I'll probably, for the lack of time, I'll probably skip over the architecture. I think I already mentioned this, so you can follow up in the slides later on, or we can take up questions next time. So most importantly, DRAND has a solid governance model. We want to make sure that we actually have a set of participants that are diverse in nature, which means that they operate in different geographies. They are under different government jurisdictions. They have their own different interests. Not everybody wants to mine Bitcoin, for example. So there's a lot of pro bono work here as well involved, because we want to have stewards, long-term stewards of the protocol. And of course, we also want them to be able to run their infrastructure, the DRAND nodes and relays, on infrastructure that is diverse, which across on-premise infrastructure or cloud-based infrastructure, so to speak. So yeah, we are accepting applications. So please reach out to us on the email provided here, and we will be very happy to talk to you and take the next steps. Very quickly, I want to talk about Filecoin. I think I'm not going to go into a lot of detail about Filecoin because this event has plenty of other opportunities for you to learn about Filecoin. But where does Filecoin get? Where does it need randomness? So Filecoin has multiple different requirements for randomness. I mean, it's actually a lot of different requirements, which some of these which I mentioned on this slide here. So as an example for today, we'll actually focus on the leader election mechanism that is actually used. And for the leader election process, Filecoin uses the VRF functions, so verifiable random functions, which take in a particular seed. And I'm only going to talk more about the seed because having a good quality seed for the VRF is what determines, how relevant or how strong my randomness or my efficacy of my leader election actually is. So with that in mind, the source of the seed is sourced from the DRAND randomness. So the DRAND randomness signatures are the source for the seed for Filecoin. And the reason here is that we obviously want to have certain properties that we exhibit, such as the secrecy, the identity of the leader that is to be elected on the Filecoin block for creating a new Filecoin block cannot be known ahead of time and cannot be divulged to anybody else. This particular seed should make sure that the process is verifiable. That means the elected leader is able to prove that they have actually won that particular election or the particular round in a fair and verifiable manner. It should be fair, like I mentioned. So, which means that the function, the seed should be able to be used in a VRF, in which they are able to win the creation of a new block proportional to their weight. So, if they have a very low weight, for example, they obviously will not be able to win that particular election or that particular block creation for that particular epoch. And of course, this entire process should be efficient, which means that we don't want to have communications happening between various miners, which means that the source of randomness, the seed that each miner is going to use, it needs to be that VRF needs to be run by miners in their own local environments. We don't want this communication happening across miners, and that's why the distribution aspect of DRAND becomes very important, in which any miner across the world can actually consume the DRAND randomness as the seed for the VRF. So with that in mind, I think we can talk about towards the end. We can talk about how Filecoin actually uses DRAND as the source of randomness. Like I said, the Filecoin chain, blockchain, so to speak, has tip sets, and for each tip set, we actually have random values associated with each of the headers, the Filecoin headers. And each of the randomness values that are in the Filecoin headers are actually sourced and correspond to a 30-second interval epoch, the epoch of DRAND. So when DRAND actually emits that particular final signature, that's actually consumed by Filecoin to create its own in its blocks, and it's then basically mapped to a DRAND round. So each epoch in Filecoin is mapped to a DRAND round. And then these particular DRAND randomness values are used to for the VRF function that I mentioned about, for leader election and proof of stake that I mentioned. It's very similar to proof of stake, but here the stake is actually a storage power. So what this means is, as with any proof of stake blockchain, the random seed, when it's actually used, the miner can actually check if they're actually able to create the block, and if they're able to place the randomness inside the block, which means that when the output of the VRF function should be, I need to be able to check that my power as a fraction of the total power is actually less than the value that was predetermined and is publicly known on the Filecoin network. So with this process, miners all around the world are free to run their own verification processes, right? And be able to mine blocks. And like I said, these requests.
Sorry, Sid, I don't mean to cut you off, but we are going to have to wrap up this session. Oh, great. It was, thank you, was the next slide. Awesome. So thank you so much for telling us all about that. Also, your logo is awesome. Whoever created that did a great job.